Hi there, I'm Patrick, and welcome to my science experiment. Today I'll be showing you one of the first science experiments that I did when I was a child. I think it's going to be good for you to pass it along to your students as well, because it shows that science is always working, even when you can't see it at the naked eye. This science experiment deals with molecules and ions, and what I'll be showing you today is the sugar crystal experiment. I'll be showing you all the equipment that you'll need to make the experiment happen, and also the process to get the experiment done. I'm going to go ahead and show you what you'll need now. Okay, so what you'll need for the science experiment is simply 1 cup of water. You'll need 2.5 cups of sugar. You'll also need a tall glass, a pencil or stick that you can rest on top of the glass, a long piece of string, and also a weight for the bottom. Okay, so now's the process of actually boiling the water and the sugar. I went ahead and I added 2.5 cups of sugar and 1 cup of water. What I'm going to go ahead now and do is add the water to the sugar. You'll notice the sugar dissolves quickly into the water, and that's actually good for this experiment. The more sugar that we can dissolve into the water, the more solute the water will be, and it will create a better crystal. You're going to want to go ahead and put your oven on medium. Now what I'm showing you now is a controlled experiment. Feel free to have your students do any other type of experiment or any other type of variable. For instance, using brown sugar, using salt, any other crystal forming mineral that you can think of. Just bring it to their attention and let them have the option. So I'm just going to continue stirring this and bring it to a boil, and when it does, I'll give you the next set of instructions. Alright, now our water's boiling. You'll notice a lot more clear now than it was beforehand. That's because all the sugar has dissolved into the water, and we're ready for the next part of our experiment. Alright, so I've gone ahead and I've let the solution cool over a long period of time in this container here. While your crystals start to grow, you're going to want to change your container, because the crystals will form to the container. That's not what you want. You want it to form to the string. So by changing your container each day, you won't have that problem. Next, I'm going to explain where your crystals will grow. You can use a pen or any other type of stick that is longer than the mouth of your cup. Next, you'll use a piece of string. This is also another chance for your student to experiment using a different type of variable. You can change the thickness of the string, the type of string. You can let them use metal or wood, anything that they really want to see if the crystals will grow faster or slower on. And lastly, a weight. This is simply to keep the string down. One thing you do want to be careful though, however, is not to use a metal that will be harmful to your student if they decide to eat the science experiment later, such as lead. Now that you have all the tools, you're ready to start growing your crystals. So you're just going to simply put the string into the solution. You'll notice on the bottom that your string doesn't touch the bottom of the container. That's important because you don't want crystals to form the string to the bottom of the container, because it can be very difficult to get it out. Once you placed it in, you just want to cover it with some type of cloth to keep the dust and dirt out. And then go ahead and place it in a safe place to rest for 1 to 2 weeks. I've gone ahead and already done this experiment about a week ago. You should start to see crystals forming like they have here on my own experiment. I want to thank you for joining me for my demonstration of this experiment. I hope you and your students also have a successful and fun time, and just take this opportunity to really branch out and make the children ask questions about why and how, and make them throw in their own variables instead of just doing the controlled experiment for a more fun environment for everybody.